Okay, I think we're going to start. Welcome to our tutorial. Happy to see everyone here at PyCon in Cleveland. I hope you have a nice time here. Me and Austin actually live here. So we'll get started. So my name is Ian Zelikman. I've been working with Python, I think, for a little bit over 6 years now. Started working more on back-end web services. And in my latest role, I work more on ETL workflow processes, processing large amounts of healthcare data at IBM Watson Health. And I work with Austin.
Yep, I'm Austin Hacker. I work with Ian on the same team, so we both do some ETL process stuff. I'm a little bit of a newer developer. I've only been working in industry for 2 years, but I got started working in Python in college, so I've been using Python for about 4 years now. And a lot of kind of what I focus on is more workflow automation, trying to actually automate all of these processes, all these batch processing that we do.
Okay, so we'll get started with a few intro. So this is what's called a DAG, a directed acyclic graph. And it's very similar to something that we have in our production environment where we have a node. So all the nodes here, that's what's executing your basically some kind of logic. Here you can see some setup that we're doing initially. And then we have a bunch of errors that indicate dependencies. And then basically all these branches are doing very similar things. And at the end, we're doing some kind of some wrap up that's generating some metadata based on all of this data that was extracted from the database. I think about a year ago or so, me and Austin were looking at better tools to work with our workflows in production. And some of the tools that we looked at were Airflow and Luigi, which are both Airflow workflow engines. So that kind of what brought up the idea for this tutorial, where we wanted to give a hands-on experience to people who are looking at these tools and give them better ideas how they can utilize all of these features in production. So the structure for the tutorial is pretty simple. We split it into 2 parts. In the first part, we'll talk about Luigi, and we'll introduce some theory, and then we'll do an exercise on it. And the second part, we'll talk about Airflow, but it will be a very similar structure. Very quickly, we'll start with the first part, Luigi.
Okay, mic's good. Cool. So yeah, as Ian said, we're going to start with Luigi. Luigi is a workflow tool that was originally designed by some engineers over at Spotify. This was designed as an internal process to handle a lot of their Hadoop jobs because they saw that they had these workflows that were pretty extensive that would involve running a lot of different MapReduce or other style of jobs, and they needed something that could manage it better. So they ended up developing Luigi and open sourcing it in 2012. So they pushed it to GitHub and everyone could use it. Now Luigi is built off of Python. That's really one of its key features. Other tools at the time were more Java-driven, and specifically the way that you would define your workflows would be through something like XML. So they're very static workflows that were not very easy to work with a lot of times and not very pretty, unlike our pretty Python code that we get. And so overall, since it was designed around a Hadoop ecosystem, it's got a lot of really good support for it. So it's got a lot out of the box to read from HDFS or to run MapReduce, or even now we've got a lot of Spark and PySpark abilities that Python just gives you. So let's talk a little bit about the structure of Luigi and how it actually operates. So Luigi uses a more object-oriented structure to define its tasks. For every job you want to run, you define an actual class for that job, and you'll find what it does. We'll go into what the actual structure of that looks like a little bit later as we start writing our own DAGs. But the way that these different tasks talk to each other is that they use files on the file system. So when one task finishes running, whatever it's doing, it'll write its output to a file. And when that file is fully written, then any downstream dependencies will see it and know that they can then run. So that's how it kind of passes back and forth what the state is and how it can actually do things when a job is completed. Now, with a structure, there's two different central components to Luigi. There's a scheduler and there are workers. Now, you might think that a scheduler is something like cron, where it'll actually run your DAGs for you, but that's not true with Luigi. The scheduler is really just scheduling work for the workers. So when you tell it that you're going to be running this DAG, you're telling the scheduler it, and it sees, okay, here are the valid tasks that I can now run, and it finds a worker that is currently available and gives that work to the worker. Then when that worker completes, it notifies the scheduler, and the scheduler figures out what else can run and, again, queues up something for that worker if possible. And so that's how Luigi really works under the hood. Now, the scheduler has two different options for how you run it. You can either run it locally, in which case it's just this single thread process that actually also does the work. So it's very limited to run it locally. It's more for testing. When you use the central scheduler, then you actually get something that's independent of your workers, and it has this nice visualization page that is just a web UI, so you can see the status of currently running jobs. You can see what has recently ran, what's currently running, and what's pending to run. However, you can't do much more than that. It doesn't give you the ability to trigger any DAGs there or really see full DAG definitions, as we'll see later on Airflow gives you. So it's more of just seeing the status of what's happening with Luigi. So when you do need to schedule things, you'll need to use something else like cron to actually schedule your work. So this is going to bring us to our first quick lesson. It's just a very basic to make sure that we all are set up properly and can use this tool as it's intended. So if you haven't already, go ahead and pull down the repo and build use Docker Compose to build your images. We also have some images on USB sticks, which will be a little bit faster to load up if you need them. And then there is this hello world DAG in the DAGs directory. Go ahead and run this command to run that DAG in your scheduler, and then and then just go to the visualization and see that everything ran, and you can look at your output and see what happened. And if you have any questions, of course, please ask us. Hello, hello. Okay. Real quick, guys. There's been a few similar questions, so I just want to clarify a few things. If you get an issue where there was no container found when you ran docker exec, then chances are this name is not correct on your local instance for some reason. Just run a docker space ps. It'll show you all your active running Docker containers, and you can use whatever looks vaguely like Luigi Scheduler 1 instead. If you got an issue with class task not found, something like that, then you need to include this, but don't include the angular brackets. That was a typo. That is my mistake. Just have hello world task at the end of your command. And if you have issues with something when you spun up Docker Compose that it said operation not permitted on a chmod, then that's due to directory permissions, most likely, in the directory you pulled your repo into. So make sure that any anonymous user can write to that directory that you pulled your repo into. Hello, hello. Okay, how is everyone doing? Do we need another minute or two, or do we generally feel pretty good about all this? Sorry, what? Another minute or two? Okay, I'll give us 2 more minutes, and then we'll move on to the next step. Hello, hello. Okay, one more quick thing that I realized as well. This is not quite the correct thing. That should be PyCon, not PyTennessee. Forgot to update that, sorry. Okay, guys, I'm going to move on now. Hopefully, you've all gotten things set up relatively well, and we can actually go on to writing our own DAG. So the way that we define a task within our DAG is like this. We have to create, like I said before, a class that represents what the task is, and that class needs to subclass Luigi.task. That way Luigi knows that this is in fact something for it to pick up and something that can actually run. And the Luigi task has to consist of 3 different methods: requires, output, and run. What the requires does is it simply defines, here are the upstream dependencies for this task instance. So before this can run, it needs to wait on those dependencies, and then once those all finish and there's those files out there that I had mentioned before, then it can actually run this task instance itself. So you're just defining an actual instance of one of those classes in your return. For the output, you're going to specify where it should write out the output for this task, where it should write out whatever you're going to end up running. And the way that it's specified there is you use a luigi.target type, and you give that target the path to your file. It can be relative or it can be absolute. For your final output, I highly recommend that you use absolute file paths, whereas for something like an intermediate step, you can use a relative file path, and it can make things a little bit easier in that sense. But if you really want to control where your files are getting written to, use absolute paths. The other thing is that this right here is a local target, which means it's going to be using a file on the local file system. However, you can also specify other types of targets, like HDFS targets, if it's going to be on a different type of file system. So go ahead and look at the different targets on the Luigi documentation if you need something else besides the local file. Yeah, question? It's going to be an instance of that task. So you have to specify it, with your parentheses. You can't just say like the actual task class. But you can instantiate it right there like that. Yeah. So does that mean you could parameterize the dependency? We're going to get there. We'll cover some of that specific stuff a little bit later as we learn how to build out these DAGs. So don't worry, we'll get a little more meat on these bones. But anyways, that's how you define the output for this task, and that's going to be the file that gets written to. Now finally, you have to specify the run method, and the run, as you would expect, actually does the logic that you want it to do. So you should put everything you want in there. Now, one thing to note here is that none of these methods take any parameters besides self, of course. And we'll see how parameters get passed in later. So when we're actually running a task, though, the way that we handle the files that we get and the files that we write out is we can call this with self.input to actually get our input data. We open it up and we treat it like a file stream. Same thing with the output. Call self.output, and you can open up that local target as a file stream and just write out to it as you would a regular file in Python. So it's pretty simple to work with in this structure if you've written to files before. One thing to note about this is that before, when we define our methods, we have requires, output, and run. But what we actually use for reading and writing is input and output. That's because, remember, requires is giving us an actual task class, but when we use input, it converts it so that we have that file stream. So make sure you remember that. And then output, you just use the same thing because it's already a target type. Now, you may also want to have some tasks that are not reliant on data from your actual DAG instance. You might have some external data that you're waiting on before you can actually run this instance. So in that case, you want to specify an external task. The way you do that is similarly to how we defined a task before, you're going to subclass Luigi task, but this is going to be Luigi.external task instead. That tells Luigi that it's not really waiting on another dependency per se, but it's going to wait on a file that'll come from some other process. And all you have to redefine here is the output and give it that local target to whatever your file is. So when you're putting it all together, if you have your external file that you want to read in, you create this external task class for it, you return your output for that file, and then whatever task is actually going to use that file, you just need to specify in the requires for that one an instance of your external task class. Now you can actually read it in and do some processing with it. Yeah? How do you know that So what will happen is if the file doesn't exist, the external class will just sit there and wait for the file to exist. Now it's going to assume that once the file does exist, it's done writing to it. That is one of the restrictions that we'll go into a little bit with best practices using Luigi a little bit later as well. But that's a great question. Once the file exists there, this task class thinks it is ready to run. So now that we've seen the basics of how to find a DAG in Luigi, let's actually try and write our own. So the lesson here is going to be to do some XKCD style substitutions on an input file that you get in your input. If you go to the actual exercise2.py file in the DAG, you get some basic helper methods for where your input's going to be, what the substitution dictionary should already be. So just create your DAG and let it do its thing. There is a hints directory that has some things that may be relevant to you, so you can see what that task structure is that we just gone over, as well as the solutions directory has solutions if you get stumped. Hello? So real quick, if you have an issue where you maybe made some typo somewhere and you get in this state where you have your first task succeeding and then the next task after that is sitting and pending and will never actually run because of that typo, it's a little bit hard to actually kill an already running DAG and Luigi. And so the easiest thing here that we can do is really just run docker compose down, docker compose up. That'll reset the state of everything and you can try again. It's not great, I know, but it's kind of a limitation with Luigi. It's a little bit hard to kill an actively running process without literally going in and running like kill-9. So we will talk about that stuff again a little bit later. But for now, docker compose down, docker compose up. Okay, guys, how are we feeling? Are we ready to move on or another minute or two? Okay, yeah, after this point, things should get a little bit smoother because you already have something that you know how to run. So I'll give you guys another 2 minutes, but then we should really move on to the next task. Okay, everyone, I would like to move on at this point. Now, if you are still having some issues, you can always copy over the demo solutions file in the example 2.py, and then you at least have there as a jumping off point for these next few sections. If you were pretty close, then you can always continue trying to work on it a little bit as we go over the next step, as this is kind of fairly, it's a fairly simple concept in my opinion, so I don't think there's going to be a whole lot of struggle, hopefully, on this next section. So what we're going to go over next is a way to make our DAGs a little more dynamic, because what we have right now is nice, but it's very static. There's not a whole lot that's different from other solutions where you're defining things in XML and you just had to say like, here's what I want to run here, here's what I want to run here. So we're going to try and liven up the party a little bit by parameterizing our task instances. So the way that we specify different parameters in Luigi is we add this Luigi.parameter bit to our task instance. This tells Luigi that whatever our task is, we'll have some sort of parameter that it can use in any of the methods that we need to define. So in this instance, we create this foo parameter. It defaults to bar, so if you don't pass anything, it'll get bar. And then when we define the output, we can actually modify and dynamically set what our output's going to be here. You'd also, of course, modify your run statement to use that parameter, or even the requires statement. Just treat it like any other Python attribute. Now, there are more than just Luigi.parameter here, because Luigi.parameter is going to be a string when you pass it in, unless it's something else. But if you want to specify that it's going to be a specific type of param and to cast it to that type of param if it's something else, so if you get a string and you want to be an int, then you make it an int. You can specify an int param instead, or you can specify Boolean. Any of the primitive types have these specific param types, and there are also some more detailed ones, like for if you want to pass a dictionary, or even things like date times you can pass through. And there are ones that have some sort of control structure. So there is an optional params and there's a choice params. So you can really specify what this parameter should be and add a little bit more functionality than what Python would normally give you off of just a regular old type. Now, how do we actually pass this parameter in from somewhere else? Well, there are two places that we could potentially be using this parameter from. One is we could have an actual downstream parameter that when we have our requires, passes the parameter directly, like in this case here with this downstream task. And that will obviously set this other task to have foo equal baz rather than foo equal bar. But the other thing we can do is when we actually make our call on the command line to run our task class, we can specify dash dash whatever the parameter is and then the value. And this will automatically see that whenever we have a foo param, make it baz instead of whatever else it would be, no matter what the task class is. Now, if you do want to set it for a specific task class, you can specify dash dash, I believe it's class name dot whatever the parameter is. And so that gives you a little more fine-grained control over these parameters. Yes? Well, yes, if you want to run the downstream task. If you just want to run your task class, you can just run task class. You don't need to always start it at the same point. If you want to start somewhere in the middle of your DAG and not go all the way through, you can specify anything else. Since this was obviously just a quick example of showing that, I didn't really care about if it was going to be downstream or task. But yes, if you pass this downstream task there instead of task class, it'll still pick up that foo parameter and push it into task class properly. So that's really just how parameters work. And using this, we can have a lot more dynamic workflows and not have to re-specify a bunch of task classes every time we have some slight difference. So for our next lesson, we're going to add a parameter to our DAG. If you look at the example 3.py now, there's just a slight change. Instead of having one substitutions dictionary to do substitutions, there's going to be 2 of them because there's multiple XKCD substitution comics. So based off of the parameter being passed in, you should change what sort of substitution is happening. Real quick, so this is something that I guess a few of you have run into so far. If you set your parameter name to have an underscore in it, and then you try and pass that through the actual command line, you need to make that underscore into a dash because Luigi just kind of translates it in that way. It's a little caveat. I didn't even think to mention it to you guys, but just make sure you're doing that. And if you have task class not found, which I've heard a few of you hit, make sure you're calling the task name at the end of the call correctly, because if you give it a task name that doesn't exist, it's going to give you that. Or if you forget to add that in, it'll tell you, give you that message. So real quick as well, guys, if you hit an issue where it says string does not have method exists or something along those lines, that's probably because what you're returning in your output for your external task, or it could even be your regular task, is just a string and not a Luigi local target. So make sure it's Luigi local target. There is an issue in my demo solutions for that, so I apologize for that mistake. Okay, guys, I'm going to move on to the next bit here. If you're still working on this, then go ahead and keep working if you need to. But the next bit is actually going to be something I think is a little bit more special about Luigi in general, and that is the ability to actually specify more than one upstream dependency. Now, that may not seem very special in of itself, but we'll go into why Luigi does this in a really elegant way in just a second here. So first of all, the way you specify more than one dependency is that when you have this requires where you normally would return that task class instance of any upstream dependencies, you can also pass in some sort of iterable to the requires, and it will parse that properly and say all of these things are going to be dependencies to my Luigi task here. And so in this way, you can have a lot more flexibility and a lot less linear of DAGs. Now, the special thing about it is that you can be very dynamic in how you specify these things, since you have this Python backend. So in here, this example, we have our requires where we use a list comprehension to define how all of our dependent tasks. Now, the interesting thing here is that we have dependencies set as a parameter to this task. We're defaulting it to 4, and then in our requires, we say that we're going to end up creating a new task class instance for each number in our dependencies and pass it into that task class. So with your runs, you can have at runtime, as this DAG is getting processed, something different happening at this level. You can actually have different DAG runs that would have different dependencies based off of the state, based off of what has happened or what exists on the file system, anything like that. And that is something that's really unique to Luigi in a lot of ways. You can't do this in XML, usually, unless you do something really hacky. And even as we see with Airflow, there are some restrictions in how you define a DAG that Luigi doesn't have here. Luigi allows you to specify all these sorts of things. Not only that, but in these last two examples, we've been using a list to specify what all of our dependencies are. And we don't necessarily need to have a list. You can have just any sort of iterable item. So in this instance, we can use an actual dictionary to define all of our dependencies. And that way, you have an actual key associated with what your upstream dependency is. And so when you actually are using your input and fetching that when you're running things, you can fetch different dependencies by that key. You can also pass in things just like this as some standard Python, and that'll get unpacked just fine by Luigi. There's a lot of different ways that you can specify your dependencies. It's actually really, really nice once you start really getting into it. Now, when you actually have multiple dependencies like this, you need to have some way that you can actually run it properly. So what you end up doing is, sorry, this is supposed to be run here. I guess I'm using an old version. You will actually iterate over all of your inputs and then open each of them separately. And then you just do the same thing that you were doing before in your run method. So in this way, you go through, you loop through, you read, process, do whatever you need to, and then once you have all of your results, you can write that out as output. And that's all you have to do to use multiple dependencies. Now, one of the big things, and this came up a little bit earlier, is that since Luigi thinks that a task is ready to run when its dependent items have their files available, you should really read everything that you need from your upstream dependencies before you write them out. Because if you read a file, write the output for that, and then continue processing over all of your dependencies, anything that's dependent on that task class will end up saying, okay, now I can run, because this upstream dependency has a file already existing that's already been written to. So you have to be a little bit careful how you handle this sort of structure. But if you are reading in a lot of input and you don't feel that it's safe to hold all of this in memory, there is all of the Hadoop support that I had mentioned before that with Luigi. And so if you're doing that sort of batch processing, you can use something like a Hadoop job task to handle this a little bit better. And Luigi will deal with those files properly. And so that's something that I would recommend if you're really doing large batch processing like this. Or any of the other types of Luigi tasks. So if you're trying to run Spark jobs, you can, of course, always do that instead. So this brings us to our fourth lesson, which is going to be, let's read multiple files, because obviously it's something that we're going to want to do. So the next exercise module, exercise 4, will give you an input method that's different than the one that we've been using. Instead, it's going to return a list of various files, and you should use that to create different task instances off of that and set all of those as dependencies. You will probably want to use parameters, which we had just gone over, to specify these external classes, so you don't have to create one for every single different file, of course. But you can always do that if you really want to. So go ahead, and then if you have any more questions, of course, ask Ian or I. Okay, I'm going to move on to our last and final section of Luigi, and then after that we'll be able to take a break and go get some snacks. But now that we've done all of this, we've been able to define a pretty complicated DAG that has multiple dependencies that are resolved dynamically based off of a return method, anything like that. So that's all good and nice, but what happens when something fails? What happens when you have an error and some task does not run properly? You're going to want to be able to do something about that, whether it's just reporting or even actually run some piece of code that maybe can try and recover it a little bit. So before we really focus on errors too much themselves, let's talk about event callbacks. Event callbacks are this concept in Luigi where when a task runs and completes, depending on the type of event that it creates, you can have some bit of Python run. So in here, we have this celebrate success method that has a decorator on it that says luigi.task.eventHandler, and it passes in luigi.event.success. So whenever you have this success event for any type of task, it'll call celebrate success. And it'll pass in the actual task instance itself. So you have an actual item, and you can actually look at the parameters of that or any of the other definitions within the task to get some sort of context about what this class is doing. And then you do whatever you need to do. Now, there are, of course, more than just success events. There are also failure events. So when a task fails, you can do the same thing. But in this case, you're actually going to take two parameters. You're going to have that task instance like before, but you also have the exception. So you have now a little more context about what really did fail, not just what task failed, but why did it fail. And so you can use that information to do whatever you need it to do. Now, one thing to note about this only happens after the failure has completely happened. So if you try and recover from the failure in some way, the task has still failed. It doesn't matter that you fixed everything. It'll still report that something went wrong and no dependent tasks will end up running. And for that task to run again, you'll actually have to go into the scheduler and re-enable the task, because Luigi will disable failed tasks by default. So there's still a little bit of manual process around it, but you can deal with tasks in an elegant way. Or you can simply have some sort of reporting framework. You can make an HTTP request over a Slack webhook or something along those lines saying this task failed for this reason, which is generally kind of a nice thing to have. Now, one thing to note is that since decorator uses luigi.task, this happens for every single task, which can be kind of a pain in the ass. So we can narrow down the type of task that we actually call this event handler on by simply replacing our luigi.task with this task class.eventHandler. And so then our task class will be the only one that actually triggers here, as well as any other subclasses. So if you define a nice hierarchy of what your tasks actually look like and actually have like some nice subclassing going on, you can handle the events for a type of task or a very specific task depending on your DAG, which can be very nice. It's definitely a very handy tool to have. Now, you might have something that happens where you get a failure, but it's just something that happens. Every now and again, you cannot make this database call because a node in your cluster went down or whatever reason. And the best thing to do is just try again. So in that case, you can simply add a retry count to your task class, and all of a sudden now, your class will retry automatically when it fails. In this case, it will retry 5 different times before it finally decides, okay, I can't do what I need to do, and I'm actually going to fail out. So that's a really nice thing. There are also a timeout that you can set to buffer how much time happens between these tasks, and various other little things that you can look into on the Luigi docs to handle these failures in this way. Now, unfortunately, the retries and the event handlers are very separate, and it'll retry every single time until it actually calls the event handler. Because again, retry count, when it retries, it doesn't mark the task as failed yet. An event handler only will call on that event when you've marked your task as having failed. So you can't try and recover using an event handler and then retry again. It doesn't work like that, unfortunately. So that is one of the restrictions with Luigi in a sense. So for our final lesson, what we're going to do is try and recover from a failure. You may have seen as you pulled down this Docker repo and done your first Docker compose up that there was some weird file there, example3.txt, that was causing some issues with permissions. Turns out there's a reason for that. Our last lesson in our example5.py will have another input file that we're also going to read along with the ones that we just used. And that one does not have read permissions set properly on it. So you can't actually read it. So the question is, what can we do when we see that type of exception happen? And so you should define your own event handler or do whatever else you want to do, honestly, to try and recover from this sort of situation. Okay, guys, so we're about to go into the break. During the break, if you want to continue working on this, go for it. But I was notified that snacks go quickly, so you might want to grab your snacks first before you do that. Now, well, but real quick, just before we do, I just want to really fast cover unit testing. Basics of unit testing is split out the actual logic from the tasks, because testing tasks are really hard. And testing real logic, when you just move it into another method, really easy. Now, if you do want to mock out a task, it is possible, but it's kind of tricky because you have to import this mock target, which tells it to store the results in memory rather than storing it on an actual file. And then you mock out your task class, you return this mock target as the actual output instead. And then for the actual downstreams, you have to patch the downstreams requires and tell the requires to do this input mock. So there's a lot of steps to it. There is a test example for the hello world in the repo if you want to take a look at it. You can also patch out the output of a task to add in this is temp equals true flag instead of actually passing something real, and that'll just push the file to a temp directory on the file system rather than a real space. So these are options you have, but I don't recommend testing tasks unless you really have to. Otherwise, just split out your real business logic from the Luigi logic. And if you want to try writing tests during the break as well, go for it. Use that hello world test as reference for what you need to do, but you'll probably see that it's a huge headache. So with that, go get your snacks then and break time.
Check, check. Is it good? Huh? I think it's fine. Thank you. Okay, I think if everyone are ready, I think there are a few more people who are out, but we have a bunch of stuff to cover, so I want to get started at least with the initial intro. So, uh, sorry, Austin talked a lot about Airflow. I hope you got the initial insights about the. Sorry, he talked about Luigi. Hope you got the initial intro to it. You learned how to write DAGs with it, the features that it supports, and kind of have an idea for the use case when you use that. Now we're going to jump over and switch gears and talk about Airflow. So, and you will see a lot of similar things because a lot of it was designed for a similar use case, but it is different, as you will see very soon. So, a little bit of history. Airflow was originally a project inside of Airbnb. They started in, I believe, around 2014, and it was open source from the beginning. At 2016, I think they basically contributed to become as a Apache project. And since 2016, it's been in a status of Apache incubation. What that basically means is they're bringing the project into a certain level of standards, but the fact that it's in incubation doesn't mean it's not ready for production. There are definitely a lot of companies that are using it in production, as you can see from their GitHub page for Airflow. And another fact that I should mention is the fact that I believe recently, or maybe it's been a while, they basically changed the name from Airflow to Apache Airflow. So if you go to PyPI and you search for Airflow, you might find the old package. The relevant one is Apache-Airflow. So that might be a little bit confusing at first, because the original one ended at version 1.8. In order to get a more recent version, you need to search actually for Apache Airflow. Then the mission statement is basically programmatically offer, schedule, and monitor workflows. So it's very similar, as you get the idea, to what Luigi does. It's more distributed, so you'll see it has more components. It scales, I think, a little bit better, and we'll see it in a moment. And they emphasize in the documentation that it's not a data streaming solution. So it might be that it is a more common mistake that people might have when they see Airflow at first. The fact that we want to emphasize that it's not competing with stuff like Spark streaming, where you're passing data from one task to another. There is, we'll see towards the very end, there is a way to pass small amounts of data, small, maybe a variable or so, from one task to another. But the main idea is you want to make your tasks as independent as possible. If you want to have, like, for example, pass in a database table with millions of rows from one task to another, that is not the solution. That's something like Storm or Spark streaming. So Airflow components. There are several components that you are able to see when you look at the Docker Compose file, and we'll talk about each one of those a little bit. First of all, we'll see the UI. This is a basic Flask application, so many of you might be familiar with Flask, so it will be easy for you to go and actually even see the code and how that is implemented. Then there is a metadata database. So the database stores all the information about the runs, and the default implementation is using Postgres database. They recommend using either Postgres or MySQL, but they also support a lot of other databases. If you already have an environment and you don't want to spin up a new relational database, you can use probably that database, and there is already hooks and support for that. Then the heart of Airflow is the scheduler. And the scheduler reads our DAGs directory constantly and updates for new DAGs or if DAGs have changed. And it is responsible for knowing when a DAG should run and when a specific task in a DAG should run. It manages the dependencies of those stuff. It also schedules, it knows about what executor and how the tasks should be executed. So there are several executors. There is the local or sequential executor. Those are, you would use them usually in your dev environment where you can execute one task at a time. If you have, usually in production, you would want to execute a lot of tasks, even within one DAG possibly. So for those, the default implementation, and probably still the most used, is Celery. And that is what we're using in our setup that you'll see today in our tutorial. There are a few more backends that they added. There is an implementation where you can use Dask as a backend for a distributed option, and you can also use mesas. We haven't had much experience with those. I believe Celery is still the most stable and the default solution that people use. And the last component is the workers. So usually in your environment, you would run one UI, maybe 2 instances of a UI. You definitely want to run only one scheduler because this is the one thing that should be scheduling your DAGs. But you can have as many workers as you want. You can even configure workers in different ways and schedules your tasks to run on this different workers. And we'll see maybe an example of that. So the workers are actually what is executing your Python code. The one thing I wanted to emphasize is that all of these, the UI, the scheduler, the worker, those are just processes. They can all live on one machine. You just spin them off using the Airflow CLI command, or each one of those can live on a completely different machine in a completely distributed environment. So that is important to understand. Now we'll see a quick demo of the Airflow UI. I think the interface is a little bit more complex and has more features than Luigi. So I wanted to show that a little bit more. I think I wanted this window here. Yeah. Okay, so, and I moved this one too. Might not be okay, I'll just do this for now. Okay, so if you have your environment all set up and running for the Airflow, and you go to localhost 8080, you'll be able to see this UI of Airflow, and this is the first page that you are basically seeing. As you'll see from the very beginning, there is a lot of DAGs that come pre-packaged with the Airflows as examples. So it's a way for them to kind of showcase for you what kind of DAGs you can write and what kind of features are supported. And it's a good reference to start with. Obviously, in your production environment, you probably don't want to see all of these. So it's just a configuration flag that you put in a config file saying, I don't want to basically see these. For this tutorial, we enabled this now for you to be able to go and use these a little bit as a reference, basically. Now, there is one DAG here that we added that is not that it doesn't come with the prepackaged stuff, and this is this PyCon Python operator. So for the first thing I'll do is I'll turn this on, and you'll notice you might also need to do it as you're writing your own DAGs. Is the fact that when a DAG shows up, if you try running it without turning it on, it would kind of just queue on you, and you won't understand really why it's not running. So that's an important thing to remember from the beginning. So now that we turned on our DAG, we can look a little bit the rest of the UI. So you'll notice here that most of these example DAGs are all have like kind of a schedule. So they either run here, for example, daily, or once a minute, once an hour, something like that. A lot of the Airflow architecture is built on the fact that it assumes by default that your DAG is going to be running on a certain schedule. And this is where it kind of doesn't fit specifically for our use case. And for what we'll do in the tutorial is the fact we want to, for now, just run these ad hoc. So we'll see how you basically set it up so you have this schedule none instead of actually having a specific schedule. So then there is the next column is here we see an owner. So that's another concept that Airflow supports. There is an owner for the DAG. And then we see here that I ran it before and we had one task that had success. And we ran the DAG 5 times and it all succeeded. And here there are a few operations and ways you can see your DAG here at the very right. So basically, if I press the first one is this lightning symbol. If I open here, I go and see, and I can actually see this Python file that defines all of my DAG. So unlike with Luigi, where you had to go and like open the files to see the DAGs, from the UI you can't edit it, but you can at least see the DAG and see how it was defined. And we'll deep dive into all of this in the next few lessons. For now, you can see that you have the options from the UI to see all of our DAG. And you'll see here we have the one task that actually implements our logic. All we're doing here is we're printing first airflow task. We're printing this argument that airflow passes for us, and we'll understand that in a later lesson. But then there is also a bunch of kwargs arguments that airflow is going to pass in by default, and we'll see what all those are about. So if we go back to this UI, now that I enabled my DAG, I actually want to run it. So if I see this play at the very beginning, and I press this, it's going to ask me, are you sure you want to run this? I hit OK. And then it started running. So you can see here now we have a new light green circle, and it says it's running. And if I want to see that what's happening, it's running, I'll open this from this date. And actually the fact that, so we had only one task in here. And the fact it's already in this dark green, that means the task already ran and it succeeded. But the nice thing you can do is you can drill down into the task, and you have a few actions here that you can specifically do on the individual task. One thing I find very useful is you have this view log. So everything that happened and was printed into standard out as part of this task, you'll be able to see in this log right here. And as we saw, we just had this print that was printing all the kwargs that were passed to our task. So you can see this first airflow task is running. DS is actually a parameter that was passing the date of when the DAG was run with. So we see that DS has the value of today's date. And we have a bunch of arguments. We have information about the DAG run, how it was, the fact that it was called in manually, things like that. A lot of parameters that you can actually use inside your task if you need that for your specific logic. So that's the interface that we have for Airflow. The other thing I wanted to show you is basically our Docker setup. I think it's here. So this is the file that you have when you downloaded the Airflow repo, and you have the Docker Compose here. I wanted to run through it real quickly. So we have Redis. Redis, we're using it as a queue to send the information from the scheduler to the workers. We won't touch that too much in the tutorial. We have Postgres. This is the database that actually stores all the information for the about how the DAGs ran, is something currently running, all of that stuff. So it's just using a database right here. Obviously, in your production, don't do this. This was just for the password. Clear text passwords are just for the tutorial. Usually, you want to do it in a more smarter way, like environment variables or something like that. So we have the metadata database, and here are the actual Airflow components I mentioned before. So we have the web UI. We have Flower, which is an interface into Celery, and we won't be working that much with it today, so I won't spend too much time on this. But we also have our scheduler right here, so this is the scheduler component, and we have the worker. So notice how here, basically, all we need to do in order to run our scheduler or any other of the components, we're just passing a command, which is an Airflow CLI command, and specifically for the scheduler, we're saying Airflow scheduler and -n15. What the -n15 is going to do is basically the scheduler keeps reading our DAGs definitions every few seconds or so. And -15 says that after 15 iterations of you reading the DAG definitions, then just die. Basically, in this case, the container dies completely, and it would be respawned again using Docker. That is a best practice that Airflow definitely recommends. You shouldn't just spin off Airflow scheduler and let it live for days or weeks or something like that. That causes for task basically not to be scheduled or some other bad behavior that I read in the blogs and we have experienced. What we have, we usually retry, basically the scheduler dies after about 2 hours. I've seen people that actually even respawn the DAG after, sorry, not the DAG, the scheduler, after a few minutes. Some people let it live for maybe a day or so. I've definitely seen people that said that letting it even live as much as a day, they saw some bad behavior with that. So they feel that that is even a little bit too long. But that might be dependent on how many tasks, how many DAGs you actually have in your production environment, and how big is your scheduler box. It kind of all depends on that. But you want to have this process basically die periodically and not live too long. So now we're going to go back to our slides. And we're going to do our first lesson. So this lesson is going to be similar to what we had with Luigi. Go and experiment with the, make sure you have everything set up, you have all the components running. Go and experiment with the UI that you can actually run the example DAG that I've just seen. You can see the logs, all the examples. It would be very important for later on to be able to see the logs, that if you have any errors, you will see them in the logs also, and you'll be able to troubleshoot maybe a little bit easier than as you had with Luigi. If you have extra time, you can actually update. So in the DAGs directory, you will see a test.dag, I believe. That is our test DAG. Just update the code to something that you think would fail, and then rerun it again and see how Airflow behaves then, once you see an actual failure. I think it will take about 10 minutes for this. We'll see how fast it goes, and then dive into the next lessons. Okay, I think we can keep going. I think most of you were able to, or as far as I saw, everyone were able to set up their environment, run some DAGs, get, now we're familiar with the Airflow UI. We can do a few more things. So now we start looking actually how we're implementing our DAGs, what we're doing to actually run some code. So as you probably figured out, the Airflow DAG is very similar to, the definition is similar to Luigi, where you put your definition into your a Python file. And that's how the basic definition works. At the very beginning of the Python file, you might want to do some imports, but then the best practice, or basically what usually people do, is they define this dictionary right here. So we define, and we call it default args. That's kind of customary. You can give it maybe a different name, but you have a dictionary of key values. One of them is owner, and then we have a start date. So as I mentioned before, Airflow is the underlying architecture is kind of assumed that your DAGs are going to be scheduled driven. So that's why it wants to have a start date, basically, for our DAG. And you can put any date in the past, and it would work for you. Otherwise, if you put some date in the future, then it wouldn't run until that date actually arrives in the system. So these are the two parameters that we need to pass. There are a lot of other parameters, but we'll see them later. So why are these default args? So we have our DAG, and we might have hundreds of tasks in our DAG. And we'll see how we define them in a minute. But Airflow kind of recognized that most of the tasks inside of our DAG are going to have similar parameters and defined with them. So the default args, these are parameters that are going to be passed over to each and every task. You can override them, but these are the defaults that once we associate a task with a DAG, they will be passed over to it. So we'll see which other parameters that gives you a lot of features that you can specify in this dictionary, but for now we'll just see these two. So now that we have our dictionary of default args, what do we actually do to create a DAG? So we have our Python file, and then we have this class of DAG, so we need to instantiate it. And the first argument is what's called a DAG ID. So that's basically a string that uniquely identifies the DAG compared to other DAGs. So you might have seen it in the web UI. You've seen the DAG had some kind of a name in it. That's where it comes from, this string over here. Then, as we defined our dictionary and we want to have all of our tasks to have these parameters, we're passing this default args. So there are a few more parameters you can, or arguments you can pass over as you instantiate the DAG. And you can see them in the documentation. But the two that you would have to pass in is this tutorial, and if you want, you probably want to pass in this default args. But the last part I wanted to show you is the fact that you pass here this schedule interval. So you pass this schedule interval equals none, and that is the reason for that is because if you don't pass the none here, and you set the start date to, like we have here, a few years in the past, the default behavior that Airflow is going to do is that it's going to say, okay, I now have this DAG, and you told me you wanted it to start sometime a few years ago. By default, this schedule interval is actually daily. So then it's going to do what's called a catch-up, and it's going to try and run every instance of a DAG that haven't run, that it doesn't see in its database for the last year on a daily basis. So because here you don't want to overwhelm your instance of the scheduler or Airflow in general, you definitely want to pass this schedule interval equals none so that it doesn't happen. The other way you can go about it is if you just pass daytime to a day or two in the past, that would and don't pass anything in the schedule interval, that would just cause it so it tries to run it once or twice, and that is fine too. But that's the default I would use, basically, the schedule intervals to none. Then, now we have a DAG. So the DAG would just give you this kind of a wrapper, and it's a graph, but it doesn't actually execute any code, right? And we want actual logic to be in it. So for that, we need the tasks, we need the actual nodes inside of our graph. And for that, Airflow defines a concept of operator. An operator is a class that defines some kind of a logic that we can execute. And when we instantiate an operator, we actually have a task, and by associating it here, our task with this DAG that we just created, that will associate the task to our DAG that we have in our Python file. So here we're using this bash operator, and kind of from the name you can see that the bash operator accepts a bash command, and that's what it's going to do. It's going to execute this bash command, in this case a date. Then we're also passing this task ID, which is again similar to a DAG ID. It's a unique identifier for this task. So in each task it has to be different. And in the second example, we again are seeing our bash operator. In this case, it's very similar, but the command is just slip5 instead of the date we had before. The main reason for the second example with the bash operator is that now in the DAG, we want to define some kind of a dependency. For some reason, I don't want to run my second task if this first task hasn't executed yet. So for this, I'm doing the t2.setUpstream t1, and that's going to create a graph similar to what we saw before, where there is an arrow from t1 to t2, which implies a dependency going from saying we have to execute t1 before we're executing t2. Otherwise, by default, if there is no dependency, Airflow is going to assume it can perhaps execute both of them at the same time. So this is how you would implement the fact that you would need a dependency. The second one I want to show you is that we obviously, since Airflow is also the same as Luigi implemented in Python, we have a Python operator. The only difference between the Python operator and the bash operator is in Python, we're passing this Python callable, and we're passing a Python function, and that is the signature. You kind of saw that in if you looked at the code for the example DAG, you saw it here. So the signature is we get this DS, and we have seen that the DS has the date of when the DAG ran. And there is also a bunch of kwargs that Airflow passes by default for us into our task, so we can reference those. And that is all you need in order to create a task that runs a Python function that you define. You can have the Python function in the same module or in a different module. You just need to import it. But for this tutorial, it probably will be easier to just define your function right before the task and then just reference here in the Python callable. A few more examples about operators. So there are a lot of operators. Some of them are what's considered the core Airflow, and some of them were contributed by the community. I wanted to show you how different and how varied they are. So we have an HTTP operator if you want to make different HTTP calls. We have a bunch of operators with, of course, Postgres is the default database that they supported. So there is obviously a Postgres operator which is executing some SQL, but there is a lot of operators for different databases where you can execute some SQL, whether you want to execute a basic query or an update, something like that. And then there is also Hive and Spark operators that you can use if you're using those environments. So the second lesson will be a little bit more interesting than the first one, and I'll give you a little bit of instructions. So there is this file that's published, I believe, by Social Security, and it's basically it's one zip file, but if you manually download it and open it, you'll see there is inside of it there is one file per year, and I believe it goes maybe 120, 130 years into the past. Those kind of hold how many people were born in the US in that year with a specific name. So what we want to do in this exercise, we want to construct a DAG that with multiple tasks that downloads the zip file, extracts it, and then calculates what is the most common name that was people were born in the US. So the interesting part would be of course you can do it all in one task, but the interesting part is do it in multiple tasks, where you have one task that is downloading the file, then another one that extracts it, and then the next task that is actually makes the calculation that we want. So you can do it in either 2 or 3 tasks, something like that, and you have to define the dependencies between them because you obviously can't do the calculation if you haven't downloaded the file first. There is in our worker container where the DAG is actually going to run, there is this temp work directory. You can put your intermediary files there, so you won't have any permission issues. You can write into this directory. And then you can either remove the files, or if you need to rerun the DAG again, you can override them. What I recommend is you manually download the zip file and see the format of how the files inside of it look. And then you kind of have the idea of how you want to structure your DAG and what's the Python code you want to implement. One more hint that I wanted to give you is if you are familiar with the requests package in Python to make HTTP calls, that is already installed, is a dependency that Airflow has. So that is already installed inside of your environment that you have when the code is going to be running. So you can use requests. Other way, you can maybe use the bash operator and run a curl command to download the file if you want. So you can combine the bash operator and the Python operator, basically. And there is similar, like Luigi, there is a solution for others also. So it'll take 10 minutes, I think, and we'll go to the next one. So I wanted to mention something real quick because I kind of had the similar questions to this. I forgot to mention at the very beginning that the scheduler is pretty good about picking changes to your DAGs, but the UI, it might take a couple of minutes for it. So if you are working on a DAG and you're updating it and you're not seeing that it's reflected in the web UI, there is a button here at the very end that is a I think it's a little bit more obvious than other buttons where it has this kind of refresh. So if you hit the refresh on a specific DAG, then the web UI is going to refresh basically the DAG definition, and you'll see the most recent stuff that you just put in. Okay, I know that a lot of you are still working on this. We'll give it 2 more minutes and then we'll go to the next topics. The next exercise is also very similar to this, so it will be kind of building, you'll be able to build on what you wrote for this DAG. Okay, as I mentioned, the next exercise, you'll be able to kind of build on top of what you probably already have if you haven't had a chance to complete the exercise. And we'll continue. So uh, now we constructed our DAG, our basic DAG, and we want to build a little bit more complex DAGs. Basically, this is where you get the feeling, similar to Luigi, that you're defining the DAGs not using a XML or something or YAML or something like that, but you're defining it using Python, which is a full feature language, and that gives you a lot of flexibility as how you want to build your DAGs. So the basic example for that is inside of your module where you define the DAG, you can actually put a for loop. So if you, for example, as we've seen at the very beginning, the DAG example where you remember we had a bunch of branches and each one was doing basically the same task operations, just on different objects, for example, a database object. So we can also define it here using this for loop. So here we're looping over just a range of 5. And at the very beginning, I'm defining my operation kwargs, and we'll see in a minute how I'm using those. But I initialize this dictionary that has task number with the integer I, so I know where I am in the loop. And now I can actually create my tasks inside of the DAG. And instead of, if I just had 5 of them, maybe I would write them outright if it was just 2 or 3 or 5. But imagine if you have like a few dozens, where you have a database where you want to do it on a few dozen tables, maybe a few hundreds. You don't want to repeat it. So here you just do it once if the tasks are very similar. You can also notice, you might have seen it before, the fact that to create the task, I don't even need to associate it with the variable. Because in this case, I don't need to specify any dependency. I don't need the reference back to my variable. All I need to do is I need to instantiate my Python operator. And what I'm doing here is first, where it's different from before, when I do the task ID, every task ID needs to be different. So I'm appending this I to my task ID string. Then I'm setting this provide context to true. And the reason I'm doing this is because of the next line, where I have this operation kwargs. I'm passing this dictionary I had from before. Now, what this provide context is going to do is, you remember we had those kwargs that we had printed. If you set the provide context to true, the dictionary we're passing in the operation kwargs is going to be passed over also to our Python function. And we can reference it inside of our function from the kwargs. So if you look here at the very bottom, in the print task ID function that I'm passing here in the callable, I'm referencing my task number, and I can get which number this specific task was called with. So here in the example, it's something basic as an integer, but you can pass in your database table or something similar if you have a bunch of URL you're pulling from them, stuff like that. The last part that's a little bit different here is this pool, which is a pool equals this pool key string. And what you can do with that is you can actually define a lot of different pools, and that would say that I want these tasks to run in a specific pool. And how you do that, you need to go back to the UI, or this is actually supported through the Airflow CLI, and we'll see that. So do this. So I go back to the Airflow UI, and I hit this admin tab. So I go to pools, and I have a few pools that I defined here before, but I'll create a new one. So test. And so I give it a name, which is a basic string, and I also say slots. So the slots is going to say how many tasks that are associated with this pool can run simultaneously. So the way you would use it, if you have some kind of a database that all of your tasks are hitting, and you have hundreds of tasks, you don't want to overwhelm the database too much. If all of them are doing some complex operations, you want to say, okay, maybe I'm running a few dozens of these tasks at the same time, but by associating them to the pool, I'm actually limiting to have only 10 of them running at the same time. So Airflow is going to be smart enough to recognize it and only execute 10 in parallel. So this is how you're leveraging basically Python to construct more complex DAGs and have a much easier to construct tasks that you want to execute in parallel or instead of repeating yourself. The next feature I wanted to show is Jinja 2. So Jinja 2 is a very popular a templating engine in Python, and Airflow uses it behind the scenes. So in the bash operator command that we've seen before, I told you can just pass a string to the bash command and it would execute that command. What I didn't tell you is before actually executing the command, Airflow is going to render this string using Jinja. So this is Jinja 2 syntax, where we have a for loop, and we have this echo. So this is a parameter that Airflow is going to inject by default. But we also can specify this params dictionary and pass in parameters that we're referencing inside of our Jinja 2 template. So this becomes very powerful if you have, I believe, pretty much all the database operators. They use also Jinja templating optionally. So you can use that in order to basically template your SQL commands that you want to run and utilize it that way. So as I said, lesson 3, it's pretty similar to the previous one, but here we have a slightly different zip file. So this one is names by state. So from the name, you can kind of figure out that this one, when you explode the zip file, you basically would get a bunch of files where now it is by state, and it has all the years with the names of people born. So now what we want to do is we want to construct a DAG that calculates in parallel as much as possible the most common name in each state. I would limit it to like about 5 or 10 states and calculate all of those. So you would want to do tasks that are on each state are executing in parallel. And if you have extra time, you can add the option where even though the tasks were defined to execute in parallel, you actually limit them so that only 2 or 3 of them are executing at the same time. So it'll take about 10 minutes for this, and let's see how it goes. This one? Go. So I wanted to point out, because someone asked me to go back a couple of slides. If you look at so if you aren't following all the parameters that need to be passed and stuff like that, if you look at the example Python operator, it's very similar to the examples I was just showing in the previous slides. So you can use that as a reference for how you would set this up. Okay, so I think we're coming up on time a little bit. So I want to go over a few more theory behind Airflow and show you a few more features. I don't. I think it's till 4:40, so we probably won't have time to dive into the other exercises. But you'll be able. We'll publish the slides, and you'll be able to go through the exercises if you'd like in your time, and then hit us up with some questions. So similar to Luigi. Once you have your DAGs running and they're hitting production, you would start perhaps seeing errors. Some of those are errors that are stuff that you need to fix in your code, versus sometimes you're hitting a database or another system that is not really reliable. So you want support for retries. So Airflow gives it to you. It completely supports this feature. So in the default args that we've seen before, the other parameters we can add, so you can set this retry, and you can set it equals to 2 or some other integer, and once the task fails, it would just retry the task for you. One thing to be cognizant about with Airflow is you can specify this retries, and it's going to do the retry count, but if you don't specify this retry delay, the time it's going to wait between retries, the default is about 5 minutes, I think. So that might be a little bit long. Depending on your case, it might actually be short, it might be long. So I would specify it to something like a few seconds, because if it's actually retriable, so it should be pretty fast. There are a few more parameters. For example, it supports like exponential backoff. So your retries, usually that's what you would want to do. You would want to have the time delay grow as there are more retries to do. But that's the basic support for it. Then, as I mentioned, the default args are just the default ones. So if you have a DAG with a lot of tasks, maybe for most of them, retrying it once or twice is the behavior you want, but some of them are actually working with a database or a system that's less reliable. So you can override this value, and you can set it to a much higher number, 5 or something like that. So that is the support that you can see for retries. The other part is that you do want to know about when stuff fail, and it supports notifying you on errors. So in the arguments, you can specify a list of emails to notify you. So when a task fails, and you specify email on failures true. But the more powerful feature, I think, is this one, where you specify on failure callback. So you can actually specify a function that would be executed once the task failed. And then you implement this function. The API is very simple, or the signature is very simple. All you need to pass it, there is a context that passed to it by Airflow. And what happens is you implement this function, and you actually have all of this from the context. You can have what is the task ID, what is the DAG ID. What our team really likes is we get notified in Slack or something like that. So very easily you can hook it up into the Slack API, or if you send it to something like Grafana, Graphite, so you can see your error trending there. You can do a lot with this. So every time a task fails in this DAG, you can utilize this function. So we had the lessons about errors. All we're doing there is just adding some kind of a random error to your DAG and adding support for errors and making sure that those actually pass. But I want to skip on this one and actually go to an interesting topic for testing. So Austin talked about unit testing for Luigi, and there is also a way to do some more testing for your DAGs in Airflow. Some of it might not be intuitive in the beginning. So there is a command line command that you can exercise from Airflow. It's called Airflow test. And with that one, you need to pass the DAG name and the task ID, the DAG ID and the task ID, and then some date on when you're executing this task. This is the way they recommend you test your tasks or your DAG as you're writing it. What this would do is it would execute this task locally for you. It doesn't register this run in the metadata database or anything like that. That is for your specific testing purposes. So this supports actually running a test on a specific task. There is no, as far as I know, there is no way to test like a DAG completely with this CLI. I'm not sure what the reason for it. I suspect is the idea is that you want to structure your tasks so they would be independent. So this might be driving this design where you are actually testing independently each specific task, and you're not doing the whole DAG where there might be some dependency. So this might be a design decision that was made for that. The topic I wanted to cover a little bit more in depth is unit testing. So obviously your DAG is basically a graph. So it's hard to construct end-to-end testing for it. As you can do it maybe in your QA environment, something like that. That would require a lot of setup. But as your business needs grows and as you construct more complex DAGs, probably you would start with the Python operator or the Bash operator or something similar. But at some point, you would need your specific business logic, and you would want to construct your own operators that are doing it. And Airflow lets you define that, basically. So the way it lets you do it is that you can actually implement your own operators. And those are give you more features than the actual Python function, because they kind of can hold the state, and you can modify them exactly to what you want them to do. It gives you more flexibility. So you can define a custom operator the way we see here. The basic thing you need to do is you need to inherit this base operator. And usually with object-oriented design, you would think this would be enough. You just inherit the base operator and you implement the method. There is one trick here that is important to know, is that you need to import this decorator that comes in Airflow, the apply defaults. What this does, you decorate the init method with this apply defaults, and what you need it for is this default args that we talked throughout the tutorial. Airflow goes in and needs to pass to your task the default args from the DAG, right? So this is exactly what this decorator does. It takes the default args that are passed from the DAGs, and it applies them to your custom operator when you initialize it, but it only does it to the ones, to the arguments that did not pass in explicitly when you were instantiating the task inside of the DAG. So this is one of the things that was hard to figure out when doing custom operators, is the fact that you need this applied defaults here. After that, it's pretty straightforward. You just do this init method, you initialize it, and you obviously need to initialize your where you're inheriting from the base operator. Then, when you're actually running Airflow, when this task is going to be run, Airflow is going to call this execute command, and this will be the actual custom logic. In this case, it's very complicated. It returns this string PyCon 2018. But you can put your own logic in here, and that's what's actually going to be executing as part of your task. Now, part of the reason we did all this is that we want to do unit testing. So when you define your custom operator, this is going to be probably a lot of new custom logic, and you want to do some unit tests around it. So this is, again, requires a little bit of knowledge and figuring out, but it's really easy to construct a unit test around your custom operators. So we're going to decouple this line by line. So the first two lines is what usually we do when we're defining our DAG. So we have our test. We need to create a DAG that this is going to run in. So we're creating a DAG very similar to what we've seen before. Then we have a task in our DAG. So we're saying we're instantiating our custom Python operator or PyCon operator. We associated with a DAG, and since we had params inside of our custom operator class, we're passing it here. So these two lines are pretty much what we've seen before. The next two lines are the interesting part. Once we have our task, now we instantiate a task instance. This is what Airflow does behind the scenes for us when it actually runs the DAG. So now we actually have a task instance. And then we actually want to run our task to make sure that the unit test would pass for us, that it does what we think it does. So we're executing this task.execute, and we're passing it this context argument that we've seen before based on the signature. So we're doing this ti get template context. And then we get a result back from our custom operator, and we can assert on that. So this is a little bit cut off, but we can basically do the assert on it, and see that the result, it actually matches what we were expecting. So this is basically I wanted to emphasize about tests. You can go through this exercise and see that you're constructing your unit test correctly and exercise with that. There are a few more. So a little bit about deployment. The basic idea is best practices is since you have a few different components, you want to make sure that your DAGs directory is synchronized between the different components. It's really easy if it's the same process on it's one machine with a few different processes, it will be just the one directory. But if it's distributed, it's a few different machines, you might need to do some kind of a custom solution to make sure that the DAGs directory that they are all seeing is the same one all the time. So that's about deployment. A few features is we've seen that you can construct your custom operators and you can introduce new pages into the UI we've seen. If you're interested in that, you can read it in the Airflow documentation. I'll skip on these ones and because we're definitely over time. And just an Airflow summary is that it definitely has a lot of features on it. We barely touched on them. There is a lot more in the documentation. It's very robust and scalable. There are a few limitations where we have the fact that DAGs are more tied into schedule, being on a schedule. And if your use case similar to ours where they're event-driven or ad hoc, you need to know how to define them. And I would like to see it being a little bit more support for automated full DAG testing, basically. So I think Austin wanted to say a few words. You just maybe use this.
Hello? Okay. Yeah, so as Ian said, there's the Airflow summary. You can see that Luigi and Airflow also have some very different methodologies for how you actually define work. There's some very similar patterns that both of them use, but one of the big takeaways is that these tools both have very much been made for certain purposes, and they're not one-size-fits-all solutions. You might have certain tasks that you would like to do that Airflow or even Luigi cannot really support so well. So just take it with a grain of salt as you're going forward with this. However, they are very strong technologies with a lot of community support. So if you have more questions about Airflow or Luigi, you can always reach out to either of us. I have my email on the slides. I think Ian has it too, and we'll publish the slides after this. There's also some other great resources on both of the repos on GitHub for these where you can contact them.
Thank you. Have a fun PyCon.
Thank you.